So hello everyone and welcome to the second module of this course. In this session I will show you the main structure of the code and how to download it on your system. But before we delve into that, I would like to lay out some facts about T-Flows before we get started. So as you probably know, T-Flows is a general purpose open source CFD package that is essentially developed for turbulent flows, whether it's single phase or multi-phase flow simulation, also including particle tracking as we will see later in the course. You'll find T-Flows pretty handy in that. The code is super well commented and very well organized, at least as I see it from a developer's point of view. And the numerical solver that it's constructing the code is based on the collocated finite volume method on unstructured grids. So you can technically run it on any form of meshes that you like. And the code also offers a range of turbulence models, so it depends on your application, but as you will see later also in the course, whether you like to run a RANS scheme, LES, or a hybrid RANS LES, you will find these options implemented already in the code, or at least the canonical forms of RANS LES schemes. So before we download the code from GitHub, I would like to show you the main structure. It's pretty simple. We have four main programs that constitute T-Flows. The first one is process, which is the main solver, the main Navier-Stokes solver, and the main bulk of the code that has all the turbulence models and multi-phase flow modules and particle tracking and everything. And then comes generate, which is the local mesh generator of the code. This comes in handy when you deal with canonical flow configurations, but if you deal with very complex meshes, then it's better if you do it in an external mesher like Gmesh or Fluent or OpenFOAM, and then you can convert it to the local format of T-Flows with convert, which is the last one on this list. So the third software is divide, which is the domain decomposer when you deal with parallel processing of your code. If you run the code in parallel, then you need to decompose the domain on several processors, and the main functionality of this software is to exactly do that, to decompose your domain onto the number of processors that you like to request, and then you start solving on these several processors. And the fourth one is convert, as I said earlier, that you use it in case that you have an external mesh that you would like to convert into the local mesh format of T-Flows. So before you deal with the case, you have to convert this mesh into the local format with the software convert, as we will see later in the course. So that's it. And in most cases we need process to run the case and generate to generate the mesh. If you're running in parallel, you need divide also, because then you have to parallelize your domain or decompose your domain and then run it in parallel. But that's just the main structure of the code per se. So with that said, let's go to GitHub to clone the code already. So you go to delnov T-Flows, and this link is provided in the archive and everywhere in the slides also, so don't worry. You will find this link in the corresponding slides, and it's linked everywhere. You copy this URL over here, and then you go to your terminal, and then in a specified directory that you'd like to work in, just try to make sure everything is consistent so you don't lose any material. But let's say you want to work in this directory. What you need to do is type git clone, and then you paste your URL here and click enter. Then it will clone the code, or let's say roughly now download it in this current directory. And once it receives all these objects from GitHub, it loads all the folders inside the code, and then if you list this, LL here is equivalent to LS. I guess it's ls minus l, I guess, is the same as ll. So you're listing here what's inside the directory, as we talked earlier about this command, and then you find T-Flows is downloaded here already. In order to navigate, you use cd command then go inside tflows, and there we go. If you list what the code contains, you will find binaries, documentation, which are two directories that I will talk to you about now. And the main thing here is sources. So if you go inside sources, you will find the four main programs that I just represented to you. Convert is one, divide, generate, and process. Libraries just contains all the libraries that the code needs to compile. Shared are some shared programs that are containing some communications or let's say modules for parallel communications. And utilities are separate small tools for plotting or for generating an inlet profile or very small functionalities, or to seed some particles, to create some clouds or some eddies. So utilities are just utilities that are used in that are there, a folder that has some small tools or utilities as in any other software. So as I showed you in the list, process, generate, divide, and convert, those are the main ones you need to know for now as the main structure of the code. And if we go one step back, I want to talk about this also here. So everything, the source code obviously, which has the four main programs, is in sources, that's the source code. And then tests has all the benchmark tests, or let's say the tutorial cases that are presented in the code and tested, so you can use them as a starting point. And my opinion is that the best way to learn tflows, as probably any other code, is to start from test cases. Those are ready benchmarks that are made for the user to get into the code and get into the structure and the syntax of the code and know where everything is. So it's better to start from here as a good starting point, and I prepared this course accordingly so I can get you into the work through these benchmarks. And what you have here remaining is those two directories. The documentation directory is self-explanatory. It has the documentation of the code and some UML diagrams, and the binaries are the binaries of the code. So whenever you compile a software, one of those four that we talked about, the executable file, which is the binary file, will reside inside this directory. And I will show you next how to hook or how to make a soft link of these binaries so we can execute them on each of our problems or each of our cases that we want to solve. So with that said, I guess the structure of the code is quite simple and easy for you, but you can always navigate through these folders just to make yourself familiar. And for now, I think the next step would be to compile the code. So that's it for this session. Thank you very much, and see you next time. Bye.